In this video, we will talk about trigonometric functions, and in this first part, we will talk about angles and their measures in degree and radian. We will also see relation between degree and radian. Hello friends, you are watching YouTube channel Math Stories. This channel features videos on mathematical concepts. Effort has been made to explain the concepts through basic mathematical ideas, so you will have no difficulty in understanding. Hope you will appreciate my efforts. We will see what is an angle, when it is positive and when negative. To understand an angle, let us draw a ray OA known as initial ray. Rotate ray OA about its initial point in anticlockwise direction to take a new position OB. Then this measure of rotation of ray OA about its initial point is called an angle. Ray OB is called terminal ray or terminal side of this angle. For anticlockwise rotation of ray OA, the angle is positive. On the contrary, suppose if we rotate ray OA in clockwise direction to take a new position OB, then this angle is called negative angle. So remember, when the initial arm rotates anticlockwise, the angle formed is positive angle, and when it is rotated in clockwise direction, the angle formed is negative angle. So here angle BOA or angle AOB is positive, whereas here angle AOB or angle BOA is negative. Angle is measured in two units of measurement, degree measure and radian measure. Degree measure. Rotate the initial side OA in anticlockwise direction so that its terminal side OB lies on its initial side. This angle is called complete angle. If we divide this rotation from initial side to terminal side in 360 equal parts, then each part is called 1 degree and it is denoted as 1 degree. So 1 degree is 1 upon 360th part of a complete revolution of a complete angle. Let's draw some angles. In degree measure, when position of initial side OA is same as terminal side OB, the measure of angle is 360 degrees. When the initial side OA rotated anticlockwise to assume a position of terminal side OB but in the opposite direction of initial side OA, the angle made is 180 degrees. When initial side OA is rotated in anticlockwise direction so that its terminal side OB is perpendicular to its initial side OA, then this angle is of measure 270 degrees. When the initial side OA is rotated after completing one rotation moves ahead to assume terminal position OB, then measure of this angle is 420 degrees. 360 plus 60. If initial side OA is rotated clockwise to take a position of OB, this angle is minus 30 degrees, and it's because of clockwise rotation. And finally, if initial side OA is rotated in clockwise direction to assume a final position OB, which is the terminal side, this angle is minus 420 degrees, which is minus 360 plus minus 60 degrees. And this angle is negative because of clockwise rotation. Let us understand radian measure. Let us draw a unit circle, a circle of radius 1 unit. Let AB be the curved length of an arc of this circle whose length is also 1 unit. Then the angle subtended by this curve at the center O of this circle is said to be of measure 1 radian if the length of this arc is 1.5 units. Then angle made by this arc CD at the center O of this circle is 1.5 radian. In this unit circle of radius 1 unit, an arc of length 1 unit is drawn in clockwise direction. Then the angle made by this arc at the center of the circle in clockwise direction will be minus 1 radian. In this circle of radius 1 unit, if we draw an arc of length 1.5 unit in clockwise direction, then angle made by arc CD at the center of the circle in clockwise direction is minus 1.5 radian. So these two are angles with positive radian measure, whereas these two angles are of negative radian measure. We have seen when radius of circle is 1 unit, the angle subtended by an arc of length 1 unit is 1 radian. Circumference of this circle, which is also the length of arc of this circle, is 2 pi. So when length of arc is 1 unit, angle subtended at the center is 1 radian. Radian in short is also written rad. So when the length of the arc equals the circumference 2 pi unit, the angle will be 2 pi radians. On the same lines, when length of arc is equal to radius r, the angle at the center is 1 radian. If this length is L, the angle subtended at the center will be L upon r radians. If we denote this angle by theta, it will be L upon r radians. So we write theta equals L upon r radians. So length of arc L is r theta, where theta is in radians. We will understand an important fact about the relation between radian and real numbers. Consider a unit circle with radius r equals 1 unit. Line PQ is a number line with point of contact A representing 0. If we rope line AQ in the anticlockwise direction along the circle and line AP in clockwise direction, then every real number will correspond to a radian measure, and conversely every radian measure will correspond to a real number. So therefore we can say that radian measures and real numbers can be considered as one and the same. Arc length of 1 unit in anticlockwise direction will represent an angle of 1 radian at the center O. Similarly, an arc length of 2 units in clockwise direction will represent an angle of 2 radians at the center O. So, in short, angle measure in real numbers is same as angle measure in radians and vice versa. Length of a unit circle with its radius 1 unit is nothing but circumference 2 pi r, but since radius is 1, it is 2 pi, which is a real number, and we have just seen length of arc of a circle in real number corresponds to angle made at the center of the circle in radians, which will be 2 pi radians. We also know that this angle made at the center of the circle in degree measure is 360 degrees. So we write 2 pi radians equals 360 degrees, which also means pi radians is 180 degrees. So this relation helps us to convert radian measure into degree measure and vice versa. Since pi radians is 180 degrees, 1 radian will be 180 upon pi degrees, which is 180 upon 22 upon 7, which is the value of pi. It gives us 1 radian equals 57 degrees and 16 minutes approximately. Similarly, 180 degrees equals pi radians. So 1 degree will be pi upon 180 radians, which is 22 upon 7, the value of pi, upon 180. So we get 1 degree equals 0.01746 radians. When we want to convert degree measure to radian measure, we write radian equals pi upon 180 into degree measure. And when we want to convert radian measure into degree measure, we write degree measure equals reciprocal of pi upon 180, 180 upon pi into radian measure. For example, 30 degrees is pi upon 180 multiplied by 30, cancelling 0, 3 ones are 3 6 are, which will be pi upon 6 radians. Similarly, pi upon 6 radians equals 180 upon pi multiplied by 6 radians. This pi cancels, 6 ones are 6 threes are 0, which is 30 degrees. Degree measure has two more denominations, means its smaller parts. Minute denoted by a single dash and second denoted by double dash. When we divide 1 degree in 60 equal parts, then each part is called a minute. Therefore, 1 degree equals 60 minutes. Further, if we divide 1 minute in 60 equal parts, each part is called a second. So 1 minute equals 60 seconds. So 1 degree has 60 into 60 seconds, that is 3600 seconds. So 1 second is so small an angle measure that it is 1 upon 3600th part of a degree. Friends, if you have liked this video, please like it, share it with your classmates. Don't forget to subscribe to this channel. Drop your comments to improve my future videos. See you in the next video. Until then, keep watching Math Stories. Thank you.